In a world where documentation sucks.
I don't have time to explain myself as I go along, and I'm afraid these men will only slow me down.
Large language models are better than humans.
I need your clothes, your boots, and your motorcycle. You forgot to say please.
And the people can't be bothered to type full sentences with actual punctuation.
Hey, you trying to flex on me, cuz? Pull up in a suit? I'm not trying to buy car insurance, bruh.
Okay, laugh and say, I'm dead.
What?
It's Gen Z, remember?
I'm dead.
Two men against all odds.
Let's do it.
Join an award-worthy podcast.
It's go time.
Hosted by a coin-operated singing code monkey.
Welcome to Go Time. I'm Matt Ryer, and
To convince the developer world they're doing it all wrong.
You can't triple stamp a double stamp. You can't triple stamp a double stamp, Lloyd. You can't triple stamp a double stamp. Lloyd, you guys, enough.
Grab your code generator.
There are many like it, but this one is mine.
And heat up that cold cup of joe on your desk.
Tastes like burning.
Because this episode of Go Time is about to blow your docks off.
Hasta la vista, baby.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from all around the Go community. Connect with us on Mastodon at GoTime, at changelog.social, on Twitter at GoTimeFM, and follow Changelog on YouTube for clips and highlights from all of our pods. Head to youtube.com/changelog and subscribe today. Big thanks to our partners at Fastly for ensuring Go Time reaches you super fast all around the world. Check them out at fastly.com. And to our friends at Fly. Host your app servers and database close to your users. No ops required. Learn more at fly.io. Okay, here we go.
well, hello there. Welcome to Go Time. I'm Matt Ryer, and today we're talking about docs. This episode is called This is Gonna Blow Your Docs Off. I'm joined by my co-host. It's Johnny Borsico. Hello, Johnny.
Happy to be back.
Happy to have you back. Do you do docs? Do you like docs?
Oh, I love docs. I'm all about the docs.
Why don't we get to see Johnny's pretty face? Can we see Johnny's face?
Can you not see him?
Yes, here it is. Yeah.
I don't see him. Do you guys see him?
Yeah, I can see him.
Oh, I just have a black box
Oh,
for Johnny.
I don't know. You're not a black box, are you, Johnny?
It says that Johnny's video will improve when his quality of internet improves, apparently. I don't know.
Wow. I'm hardwired.
Yeah.
Never mind. I have to make do with the soothing tones of your voice.
Yes, they can be.
Well, we'll send you a photo. Send you a photo of Johnny so you can...
I'll frame it for you. You can hang it on your wall.
Fair enough. Thanks.
Well, that voice you heard not respecting the format is none other than Mark Bates. Hello, Mark. Welcome to the show. Now you can speak.
Hello. Now I can speak?
Hello. It's great to have you back.
Why? Since when would I ever respect the format of the show, really?
Yeah, I know. Exactly. I don't know what I was expecting, really. On the other hand, very professional Corey. Not made a peep yet because it's not yet been introduced. It's Corey Lanew's with us. Hello, Corey.
Hey, everybody.
Welcome to Go Time. Excited to talk about docs. You know, it's docs, isn't it? This is like one of those things that we have to live with as engineers, and sometimes feels like a very big chore, writing docs. And
well, I don't think anybody likes going to the doctors. I mean, it can be uncomfortable. It can be unpleasant. Did I get the wrong show notes?
Especially with that glove on.
Hang on. Sorry, wrong show notes. Yeah, sorry, my bad.
No, you got the right ones. Mark's going to be talking about the doctors, and we'll be talking about writing things.
We're talking about all my medical issues as a middle-aged man.
It's just an hour show. We don't have enough time. Yeah,
fair enough. There's Johnny.
Oh, can you see him now?
Yeah, he's a little fuzzy, but he's there.
I wonder what's going on. Something up.
Yeah, I am a little fuzzier these days.
Aren't we all?
Yeah, but you're not low res, are you? It's like John. It's like you're feeling unwell, and how that manifests is you go low res. Like that's how you can tell that I've got a bit of a cold. I'm a bit low res, and then you have to recover.
We're all pixelated
a little bit.
Well, yeah.
But you two live nearest each other on the planet, so I would expect you to have good connection.
I mean, we live on the same coast of the same country.
Right.
Yeah. Well, there you go.
Right.
I don't know if that makes us super close or not. We're in the same time zone.
Yeah. Well, it's closer than you are to me.
We used to live super close. We used to live very close. But yeah, that's not the case anymore. Matter of fact, I mean, I don't know. Corey's in Wisconsin. I don't know which of us is actually the closest to each other. It's probably Johnny and I, but
yeah, because I'm an hour flight from you.
Yeah, Corey's in the middle of nowhere.
I'm an hour from the airport.
And that airport then takes you to another airport where you can get a real plane to go somewhere else. I've been there. I've been there when the airport wasn't open yet.
What were you doing there, Mark?
I was there too early for my flight. The airport wasn't open.
Oh, I thought you meant like they'd not even built it yet, finished building it, and you're there trying to get a flight.
No, it wasn't operating hours.
It wasn't operating hours. Yeah, they had big metal gates down over all like the two gates that they had. They had like two scanning rails. The gates are down and everything.
Wow.
Well, in fairness, it's 2 gates, but it's the same gate with just 2 different numbers.
It's not even 2 gates.
1/2 over one door.
Oh, I like the sound of that. Be like always going first class. You get your whole own experience. It'd be quite nice.
It was pretty cool. It was pretty fun.
Did they open the gates for you then, Mark? Basically, or no?
They did. It was pretty remarkable. I felt like they opened the airport just for me. I was the first one in line for baggage check on a Tuesday. It was quite funny.
Oh, that's nice.
Anyway, should we talk about docs?
Yeah, tell me about docs. Do you like writing docs, Mark?
No, I don't. Do you, Matt?
You've got a book out, you big idiot. You've got
yeah, well, right.
Sorry, I've got to be nice to Mark on this, I've been told.
Writing books and liking writing books are 2 very different things. They're not the same.
True.
You know, I've written 4 of them. I hated the process of every single one of them. By the way, the book we're talking about for all those who are listening is Go Fundamentals. Available now where all good books are sold. Just search for Go Fundamentals Gopher Guides and you will find it. Sorry. You can cut that out of the show. I had to do it.
Right out of there. Goodbye.
What's it about?
Go Fundamentals.
Is it? Good title then.
No, but seriously, does anybody serious question to the group? Does anybody like writing docs?
I'll jump in and I'll go against the flow. I mean, I actually like writing docs, but not. I don't like writing the sort of the documentation for, say, since this is a Go podcast, I don't like writing the docs for my export identifiers, right? Like, even though they're what help with generating the Go doc and all that stuff, and those things are useful, right? When you're looking at an API, you want to know what things do, right? Well, none of that, I don't like them. I think I have a preference for sort of a README development, sort of a docking, right? Or documentation, or architecture documentation, or system design documentation. I much prefer those because I think that's where the creativity, right, comes in, right?
Well, you're allowed longer form exposition too.
Right, exactly. You're not trying to be succinct, and you're not trying to, like write a manual for the specific bits. Like, you're just describing what the thing does at that point, right? Because the thinking, the creativity, all that design work has already come, and ideally you have documented that. I prefer that part.
Yeah, because you've got reference material that's what the Go docs are.
Right.
So that's useful. And it's like when you have docs generated by Swagger, and you just get an enormous index, and you're just sort of on your own. And so there's no curated experience. There's nobody taking you through this and telling you a story about the docs. It's just, here's just all the reference material. Good luck. And you never know what to do with it.
My problem too is, I don't know if anybody else has the same problem, but I'm Johnny's, but I hate writing them because what I hate writing about them is I always feel like what I'm writing is so obvious to what is happening in that function or method or identifier. Because I try to use good naming of my identifiers, right? And so that alone helps so much if you can really name something well, right? And then if you're keeping your methods and functions really short, like they're not doing a ton. And so I always feel like I'm pretty much like this function does exactly what its method name says it does. Like, what else do you want me to say? It's it's a string function. It returns a string. I mean, string returns a string, a representation. Like, yeah, obviously, but like, that's where I struggle with that short form kind of little bit of writing.
Yeah, it's that thing. It's the pattern, isn't it? We do that. We do it because it's good, and then therefore we do it all the time. And sometimes it's silly. But I notice you don't in the linting tools or whatever the tool is. Go doc check. There's a tool that checks the docs. It doesn't complain if you're implementing common interfaces. So it doesn't actually make you say string is a string representation. But there are other examples when it's not part of those kind of standard interfaces where it will just say like, oh, you need to put a comment here, and the thing's just called something really like stop, and it's a thing that you've started. It's like stops this. It feels unnecessary, but
and starts it. It's like,
guess what? Starts.
And if there's a problem, it's going to return an error. Like, what else do you want me to say? Like that's
But I think like the ecosystem, there's really like two styles of docs, like Johnny was saying, right? There's I got to document my code, right? Which is go in and give all my exported symbols something to say. But then there's I have to write the README. I have to write the blog about what this does, right? And that's the stuff that I enjoy writing that. I think a lot of people enjoy writing that. But that's also by far the hardest part to write. Like that's a lot of work. And there's two stages to documents that always frustrated me. There's the initial documentation, right? You write it, and then you come back 6 months later, right? And is that documentation up to date? No. And you think to yourself, I'm going to update this, right? But you never do. And then people come to it like, oh, I tried your example, but it doesn't work. Well, because it's 6 months up to date.
Or the example itself is broken because you never actually validated that the code could compile in general. You forgot a thing somewhere, comma, or something stupid that makes the whole thing not even. Yeah. READMEs are the worst.
It's also worth sort of calling out there's some documentation. I've seen APIs that are well documented, right? Where they have good names and like Mark's talking about, it's like self-explanatory what the thing is and does. But to Corey's point, if you have a README that's showing usage documentation, right, you might have very sort of at the unit level, each function is indeed self-documented, but depending on the complexity of the library and what it is that it sets out to do, you're typically composing, right, various bits and pieces of the library or whatever that thing is. So that's where the usage documentation. How should you be approaching this project? Because I've seen APIs that are well documented, go doc everywhere, but then the README is very sparse, and I'm like, okay, well, where do I start? How do I actually use this, right? Like what's my starting point here, right? And that right there, I think, is perhaps even like I would prefer that over like 100% documented, a Go doc, right? I prefer like this is how you use this thing, right? And then I can infer what a particular function does if it's well named, right?
I completely agree. There's nothing worse than going to a project and the only thing on the README is that the tests pass, and here's a link to the Go doc to find out more. And it's like, well, right. Like you said, well, that's great. There's all these. Now we're looking at 56 types, all these functions, methods, constants, and all these different crazy things going on. It's like, well, where's my starting point? How do I get this thing to do a basic thing? And then how do I get it to do a slightly less basic thing, and so on and so forth? Like, yeah, especially when you have large projects like that. It's one thing if you go to kind of a utility library. I mean, it's got a handful of types and functions or whatever, and they're pretty small. It's pretty easy to just look at the Go doc and say, okay, I know exactly what this is doing. It's not too crazy. But yeah, if you're trying to imagine if Docker was just like, hey, here's my README. Just go look at the Go doc for Docker and figure it out for yourself. Or Kubernetes or some massive library. It was just like, here's the Go doc. Have fun.
Mm-hmm. Yeah. That's when it has the opposite effect, I think, where it's like, this is actually too overwhelming. Like there's too much stuff here. It feels like insurmountable, and that could put people off. People just build little versions of stuff, and there are libraries and tools out there, but they're very big and they're quite intimidating. So it's like that I think is a good reason to keep things simple and small where you can anyway. But I think it's a docs issue. It's like you say, it's not. There isn't somebody saying, okay, first thing you're going to do, import this package, get this type, do this little thing. That's basically what you're trying to do here. That's the basics, and then from there we can take you on a journey. It's just kind of storytelling, isn't it?
It is. And I think that's why, as a whole, I think we'd all prefer to write those sorts of docs than the Go doc sorts of docs, right? Because we can tell a story. And we're all better at that than writing these weird, succinct little sentences that describe a fraction of an idea that is a method. Like this small little thing where you can tell a story and you say, okay, hey, we want to go from point A to point B. Let's walk through how we're going to get there. And that we're going to use this library or tool, whatever it is, to get from point A to point B. And let's walk you through it. And that is a much nicer experience, I think, for the user. It's also much harder to do. Well, it's harder in a very different way than writing the Go docs is. How's about that?
And somehow we like to throw newbies, like people who are, or at least new to a library, right? To say, hey, this is what I'd like you to do. Like, you want to contribute, write some usage docs, and then now, like, we're putting a task on their shoulders that is, like you just said, it is hard, right, to weave together a story, right? And they have to, so it's like we often elect those. We'll put a good starter, tag on these things on GitHub or something like that, and say, hey, yeah, we write this doc, but we take for granted how hard it is to truly weave together a story that tells you exactly how to use something.
Oh God, yeah, it's so hard.
I think it tells you something about the mindset, really. If you're giving a junior person like, oh, cool, just to get started, you can just work on docs. That really tells you the attitude towards docs, that it is this sort of necessary evil. We just have to tick a box. We've just got to make sure we've got all the coverage or whatever it is. So it is kind of a bit of a red flag, maybe, if that's happening.
Well, developers, I mean, I can only speak for myself, would rather code than write docs. Right? I mean, we're a fickle bunch. We don't want to do anything we don't want to do. And, if it's not coding, most of us don't want to do it. And that's where you get stuck there. And that's why it becomes this chore that you throw on a junior engineer, because you don't want to do it. You rather be coding, right? Like, let the junior engineer write so you can write all the cool code. Of course, the junior engineer is not getting the great experience they need in the code, but they're hopefully becoming better technical writers.
But I think a big part of it is like you said, it's that chore to documentation, right? And I think that's part of, what we're going to talk about today is, what if it wasn't a chore, right? I think that's a big part of it. What if it was actually easy to write these docs? Because I like to write the stories. I mean, I like to write the blogs, I like to write the presentations. But when it's a lot of work, you kind of dread that. When it's not a lot of work, then you don't dread it so much.
Well, is it that it's not rewarded?
It's tedious, right? It's tedious. I mean, think about let's take a really simple hello world introduction, right? To Go. I have to write the code, and then I have to take the code and I have to copy it and put it in my documentation. Then I have to run the code, and then I have to take the output of that code and put it in my documentation. Mm-hmm. And then if I make one change to my code, I have to update everything all over again, right? Like, it's incredibly tedious and mind-numbing. And as developers, we don't like to repeat ourselves, right? We don't like to repeat when we say things. We don't like to repeat when we code things. We certainly don't like to repeat when we document things, right? And so part of that process of documentation is so much repetitiveness over things that should be like, can't this document do it on its own? Like, why can't it do these simple things, right? So that I can write code and then I'm done. I don't have to put that in my story by hand. My story just generates all that. And Mark Bates kind of took that to the next level.
I love when I hear my name mentioned in the podcast that I'm on. What were we talking about? I wasn't
exactly,
paying
you weren't paying attention. That's why he said your name, I think.
Well, let's think about it this way. As Gopher Guides, we're a training company. A lot of people think what we do primarily is train. They would kind of be wrong in a way. What we primarily do is generate documentation, like oodles and oodles of documentation. It's all we do. And then we maintain documentation because every 6 months a Go release comes out, and all of our code gets updated in certain areas. Like, some chapters get completely rewritten, but some just need a ton of refactoring. Something as simple as, iutil gets deprecated, right? I have to search everywhere that iutil was ever mentioned in anywhere documentation and now put it in the right spot. So it's not just changing your code now, it's changing your documentation. But I shouldn't have to change my documentation. I should just have to change my code, right? And so we spend all our time writing docs. So when Gopher Guides first started, Mark went to task and wrote a initial tool that really helped creating documentation very quickly, especially technical documentation. And that just graduated over the years into this tool that we use today that almost writes documentation for you.
It is a little disturbing how.
And I'm going to let Mark kind of take off from there and explain.
Is it GPT based? Mark?
No, I know, right?
In a certain way, like if we actually enabled this to be GPT based, or even just whatever the one GitHub has there,
Copilot.
Yeah, Copilot. In fact, I think Mark used a lot of Copilot when we actually wrote some of our stuff.
No.
It's like what do you mean?
What are you talking about, Corey?
What are you talking about?
I don't know what you're talking about. Copilot didn't help.
We don't know who owns it yet.
To put I guess to kind of jump off what Corey was saying, the biggest problem with documentation is the upkeep, and that, like, when I talk about why I don't like writing documentation, it's because it's not just that initial chore, which I can do, right? You can do that initial chore, you're in the moment, you're there. It's the maintenance of that chore. As our APIs change, as Go changes, as whatever changes, like there's a chore associated with that we must do every time we make those changes. And that's the chore that sits in the back of my mind when I'm writing documentation. And that's what makes me go, oh, I don't want to write the docs. It's not the initial, it's the future, the years of maintenance that go into keeping that README up to date.
Yeah, and I've seen projects that will like they don't want to do the docs yet because the API is still in flux. But the thing is, like, it's hard to get right the point at which you should deliver the docs, knowing that things are still going to change. So making them changeable, like making that automatic, I think that's a very big win. And yeah, it's really about the maintenance cost. That's often the big one.
Well, that's because we don't include doc writing, right, as part of the task. It's like it's like a bolt on, right? I think there are memes out there even, right? For example, if you take like tests, right? You have the people, so in order of the things we prefer as developers, right? We like to write the code that does the thing, right? Next, we don't love write the test, but we know that, okay, if I need to get this thing, merged in, I have to write tests. Okay. And it becomes this other thing. Maybe you might even have a different estimate for on your board that, it's like, oh, okay, now I got to write the test, right? And then least of all is the docs, right? So you go from code to test to docs, right? And then rather than looking at all these things as just one unit of work, we'd be like, okay, let's make them three separate things. And then let's do the thing I love first. And then the thing that's the most fun. And then from there, it's just downhill, right? We just don't look at it as just one thing.
And that's what you have the junior engineer for.
Yeah. I do TDD. So I actually do like that testing bit, but I'm splitting hairs because you're right. That is essentially the process. Imagine if you could have tests for your docs.
Well, that's kind of partly where we're coming from, what kind of Corey was kind of alluding to. So, we generate so much documentation, like that, and content, like that's what we do. Like a few years ago, we wrote like 600 pages worth of articles for DigitalOcean in like 3 months. You can go online, there's an ebook of it on DigitalOcean, and it's like 600 pages where we break down Booleans in great depth, like these sorts of articles, right?
Is that true?
That is true, yeah.
Yeah, it's a Boolean joke.
Oh. Yeah.
No, I want to read it though because I want to find out what there is to know about Booleans.
That was good. You should keep making those jokes. Anywho, and then of course, things like this, right? Like this is nearly 600 pages of technical writing, right? Like, and
your book,
the book. And Corey said, that we wrote this book by accident because we were working on a 12-week course for that we were going to do. We did a 12-week fundamental course. It went really, really well. It was like a master style college level course. It was so good. But then we got so busy with the corporate and then writing the book. We unfortunately were never able to actually get back to that. But that class that I was writing became this book accidentally. And it's all because of this tool that Corey was talking about, that we've built to help us fix these problems we have with all this documentation that we were just talking about, the maintenance, the upkeep, portability, right? We write code, we write documentation But there are many places where we need our documentation. So for us, we're writing all this content, we're doing all this heavy, deep technical writing. We're publishing it to the web, maybe as blog posts or in a slide format, or we're publishing it to Canvas, which is like the world's leading learning management system, via a Rails API that they have, right? Or LaTeX. When we did the book, the publishing company, Addison Wesley, needed LaTeX. So we had to take our content and give it to them in LaTeX. So we have all these different places we need to put it, databases and APIs and HTML and LaTeX. And the last thing we wanted to do was rewrite all of that same content for all those different places and have to spend a lot of time reworking that content. Because every time you do that, if you keep splintering that content out to all these different places and it's not centralized, then that maintenance nightmare we were just talking about becomes exponential. Right. So if I want to update now a course in Canvas, that LMS system, I now have to go there and do all the updates there. And then I have to make the same updates to, LaTeX and the same, whatever it is. Right. As documentation writers, as technical writers, we need to be able to disassociate what we write from the presentation layer and where it goes. And a lot of tools out there connect those two, or they disconnect them in such an abstract way that it's like it's all via JSON and all these like configuration stuff that you're now caught up in that. What we wanted to do and what we had to do is we wanted to work in editors, and we wanted to work in our editors in Vim or VS Code or what have you. We wanted to work with local files. We wanted to be able to write in something simple and easy that we know, like Markdown, right? We all write our READMEs in Markdown. It's a nice format for doing that, but it's limited. It doesn't allow us to do things like insert code samples, snippets from files, or run output and include it automatically, or inject GoDoc directly into the documentation, or any of those sorts of things, or validate it, or allow us to pull it apart and do all these things. So essentially what we did was we just built that system. We took Markdown and added the ability to put some custom HTML tags in there. And then from there, we're able to parse it and execute the document and do all sorts of different things and then put them wherever we want. We can execute this document and have all of the code samples, and we can put in there, okay, I want the GoDoc for IOEOF, and it's going to go and it's going to run GoDoc, and it's going to capture that output and it's going to stick it in for us. If I say I want to run here, I want to show this piece of code, and then I want to run this, I want to run go build or go run dot or whatever it is I want to run, and I expect that this code sample is going to fail because I'm showing something that panics, right? So I can even say I want to make sure that it exits with a 1 or a 2 or whatever. And so we can put these nice little simple HTML tags in there. We can execute the document, and it's going to fill in all of that. And if there are problems, we're going to get back errors immediately telling us our code was wrong, the exit statuses were wrong, the image didn't exist they were looking for, the included file didn't exist. Like, there's all these different validations and kind of understanding we can get by compiling the Markdown document like this. And then we can take all those different elements and post them up via APIs, post them to a data, put them into a database, write HTML, create LaTeX, whatever we want. But the key for us was really writing and keeping things very, very simple. Local files, Markdown, and HTML. Like, there are tools already in every editor for Markdown, HTML. We all know Markdown and HTML, right? There's no learning curve. It's just practically, like I said, practically very little learning curve to do it. And we just work in our editors, and everything just kind of falls into place. And it's just such a nice way to work, to know that every time we make a change to that code, that we're being told whether our documentation is valid or not. And that's the big thing for us.
Hello, friends. This is Jared here to tell you about Changelog++. Over the years, many of our most diehard listeners have asked us for ways they can support our work here at Changelog. We didn't have an answer for them for a long time, but finally, we created Changelog++. a membership you can join to directly support our work. As a thank you, we save you some time with an ad-free feed, sprinkle in bonuses like extended episodes, and give you first access to the new stuff we dream up. Learn all about it at changelog.com/++. You'll also find the link in your chapter data and show notes. Once again, that's changelog.com/++. Check it out. We'd love to have you with us.
One of the other key concepts too that really came into this tool that I think works really well is that it allows us to develop documentation in the same way that we code. Now, what does that mean? Well, if I've got a Kubernetes project, right? When I open that up, I don't look at every single file at the same time and try to write code, right? I open up one package or one file and I work with that subsection. And then I make sure that subsection is tested, runs, all that kind of good stuff, right? And so with the way that includes work in basically partial, if you want to call them that, with our tool, is if I'm writing a section on, the file system, right? I will literally create one folder that just talks about one type. And I'll write 2 or 3 paragraphs about that. I'll put 1 or 2 code samples in that. I'll make sure that they know like what the outcome is, whether they pass or fail. And that's that one section. And I can see it all on my screen and I'm just looking at that one piece. I'm seeing the output. I'm seeing the rendered documentation for just literally, a couple paragraphs and a little few code snippets. And then I can back out of there and say, okay, now I've inserted that into the larger chapter and how did that flow? And now I can back out of that and see the larger chapter again and see how that flows, just like you do code, right? It also means that when that type of system changes, maybe they make an update in the language when they go ahead and make a new release, I can just go into that little piece of code and that one little 2 or 3 paragraphs and make just my changes right there and refactor just that little bit of documentation and code, just like you would Go code. Like you wouldn't edit 25 files at once. You would edit 2 or 3 files at once. And so this really gives you that very hyper-focused ability to concentrate on really specific topics and really be able to see them at a glance. And then you can pull back and kind of then see, how does this go into my documentation now and how does it flow? And it really lets you write really, really solid documentation and really, really comprehensive documentation when you approach it that way. And it feels like you're writing code. Like that's another thing too. Like now I don't feel like I'm writing documentation. Now I feel like I'm writing code. And as a developer, I want to write code. And if it feels like I'm writing code, I'm having fun again.
Yeah, I mean, we've got each markdown file because everything's relative. The tool handles when you include, it'll actually rewrite all the links to make sure that the relativity is proper, all the pathing is there. So, like I said, you can work on a partial, and all the links and all the images are going to be there and proper in the files. But then when you include it into something bigger, all of those relative links are going to be rewritten to be properly linked again. So you're never worrying about that. You're never dealing with kind of, oh, it works here, and then I include it here, and now these links don't work, and the images are broken, and stuff like that. But inside of those files, yeah, we're really working with Go files and other source files, because we're just including them into the markdown with an HTML code tag, and saying, here, include this source file or include this snippet within the source file. We can use comments within our code to do snippets, to mark off snippets in our Go file, so we can extract those right away and just shove those straight in too. So, again.
Well, that's better than using static lines, of course, for maintainability, right? Because if you use static line numbers, when things change around, then all your docs are out of kilter again.
Yeah.
What's the tool called, by the way?
It's called Hype.
Hype.
Hype, as in don't believe the hype.
Oh, yeah, but believe it.
Is it out there? Is it open source?
It is not. No. It's our secret sauce.
That's part of secret sauce.
It is. If anybody's looking to buy us for that secret sauce, you just let me know. GitHub, I'm looking at you. Imagine if GitHub had this sort of technology built into its readmes.
The fact that you never write your readmes again, they're all generated. So like anytime you update any code anywhere in your code base, if your readme reference that code, as soon as you check it in, that readme recompiles because it's generated.
And you have the outputs, you have those code examples, everything would be live right there in your README. Wouldn't that be nice, GitHub?
Part of it is that, I've been developing for 20 plus years and there's people who've been developing 40 plus years. The fact that our documentation tooling is this out of date yet is baffling. It's baffling, right? I mean, doc tooling is truly like banging rocks together yet. And that's where,
not ours, not Gopher Guide's tooling. Gopher Guide's tooling is amazing.
Yeah, one of our competitive advantages, I think, early on was that we could update our material so fast that, within 2 to 3 months of new releases in Go coming out, our material was already updated. And the reuse, right? So when I go in and I update, my interface chapter and start to add generics in it and start to say, hey, instead of using an empty interface, now we use the word keyword any, I'm editing code files that probably show up in 2,000 courses I've taught. And so when these people come back and see their courses that they've taken over the years, I only edited one file. That was it. And everybody got the updates because it's code, right? Just like when I update a package and it's included, that's what we do. That's how our docs are. Like they're just included. I don't write, about, interfaces 1,000 times. I write about them one time, then everybody gets that file.
The nice thing too is when you're using things like Markdown with HTML, I mean, it's super easy to diff and comment on and talk about in a PR and all this sort of stuff, right? There's just like, and then you get all the code, which you can then comment on just like you would too. So you can pull it down. You can run those examples locally to make sure your partner's not losing their mind. You can change the example. You can do all these nice things and you're just working with regular code in a branch, whatever. And then you end up with a book when you compile it, or you end up with a website, or you're pushed to an API.
Yeah. It's funny, that concept of compiling your docs. I feel like that really does kind of feel nice. And also because I like TDD, I have before done document-driven development in that I wrote the README first to kind of explain, this is how I imagine it's going to be. And that really then influenced the tests, which influenced the code and influenced the whole design. Could you do that with that? Could you just do docs first too and actually have them build and fail? Like they're kind of like tests and docs at the same time, aren't they?
Absolutely. In fact, it's interesting that this tooling has changed the way I write documentation, because I think about that, we write a lot of blogs, but anytime you write a blog, traditionally you kind of write that blog and then you go back and you read the blog and you realize you're missing these pieces, right? Because you write a bunch of stuff, then you go back and you don't really read the blog until you're done, right? And so you kind of write and you would never do that with code. You would never write pages and pages and pages of code and then run a test, right? You would be running your test as you're writing your code. And very much like TDD would be, right? And so with this documentation tool, because you've always got a window up that's showing you the documentation as you're writing it, you're writing documentation and in real time, you're watching it flow. Like you're literally watching it render real time. I read a code sample, I include it real time, it's there. And so you're doing that. And so what you're catching right away is you're catching, oh, you know what? I jumped a step. Like I realized I already jumped a step. So I got to go back and backfill this step real quick and show, hey, I'm talking about this thing, but I forgot to tell you about it. And so by the time you're done with this blog, when you go back to reread it, it's mostly done because you've been testing it as you've been writing it. And that's the thing about documentation that you don't have with other tooling. You kind of have to write this whole story and you go back for 10 different revisions and then you give it to your buddy and they have another 10 revisions. And it's really kind of a grueling process. It's not fun. But if you have real-time feedback and you're watching it literally render as you go, it just completely changes your mindset on it because you can see it, you can absorb it and consume it immediately.
So it must be better, much better quality just by that nature, right?
Mm-hmm.
Oh yeah, and you just start getting into the flow after a while. It's disturbing how easy it becomes to write in this nature. Our editor hates us. Told us not to say this, but the truth is, when the original manuscript of this book was 1,000 pages, and they made us trim it down. It was either that or we put out 2 books, and we opted for one. But it was just that easy to write the content, because we could include, and what's cool when you read the book, like GoDoc, we include the GoDoc right there for methods and types and stuff that we think are important for you to see. So you don't have to go and read the GoDoc somewhere else. It's included right in there, and when you start doing stuff like that, yeah, it's easy to add bulk, but it's, to your page count, but those things are useful to people and they're right there. And for us, it's one line of HTML that's just go doc equals IOEOF. Here you go. Boom. There you go. And it's all put in there and everything.
And what's critical about that too is when Go 1.22 comes out, all we do is recompile the docs. Whatever doesn't compile means something either changed or, if the Go docs got updated, our documentation got updated. Like even the things we depend on, right? Like GoDoc isn't part of our Like we didn't write GoDoc, right? It's just a tool that we use from our tooling. If the output of the go build command changes or the go run command changes, our documentation is 100% up to date automatically just by recompiling. We don't have to touch a line of code, a line of documentation. Absolutely nothing has to change, and we're 100% up to date. So I'm really waiting for when they come back and say, "Hey, we want you to, do your first revision of your book and update it with 1.25." Like, okay, yeah, press the button. Here you go, we're done.
Add in the 3 extra paragraphs once new and call it a day.
Yeah, exactly.
Yeah, exactly. I mean, I use this sort of tool because it's just so easy. I use it for all my writing, to be honest. I do my papers I'm doing a master's degree, and I write all my papers this way.
What are you doing your master's degree in?
Oh, and sound and audio production.
The Sound of Music
College. Yeah, it's music production or something. I can't remember the exact title of the degree, but yeah, I use it to write all my papers for that because it can be incredibly useful. I pull in, there are times I'm pulling in all sorts of weird information, and I found it to be incredibly useful and works really well. Worked really well for what I wanted it to do.
Well, just for some balance. So, like, if anyone did want to buy Gopher Guides, you would also have to get Mark. I just want to put that out there, just to sort of balance this out a little bit.
Be warned, be forewarned.
If the offer's right, you don't have to take Mark. I think the bigger takeaway that apart from this is we've built this great tool that we love and we use and whatever, is the general idea that the tooling around documentation overall is just too painful, and people who write those sorts of toolings and who are expecting others to contribute to their projects from a documentation standpoint need to consider the UX of that interaction for junior developers, for new people, for existing people. Like, what is it like to write documentations for you? Do I have to do a bunch of JSON and like all this weird stuff, or can I just write some markdown and give it to you? Like, what is that process? Try to make it as easy and as simple for you and for everybody else, and try to come up with those ways that you can make this process of writing documentation better. I'm not saying everybody has to go out and write their own this tooling or whatever, but I'm just these are things that we found were real big problems to us, and we've spent 5-6 years working on tooling to help us solve these problems, because they're problems that everybody is having, and some of them can be easily solved with better practices and a little more time and care. Like Johnny, I think it was Johnny who was saying earlier, like, instead of kind of pushing docs all the way to the very end, let's bake some time in for them into the process. We were able to get testing baked in finally into our process. That took years. I know I used to lie through my teeth to people about estimates just so I could add testing in there. Because as soon as you would say to somebody, "Oh, I want to add testing in 2005, 2006,"
you don't need
the
that.
CEO would go, "No, absolutely not. Get it out the door. We don't have time for 2 more days of testing. What are you, crazy?" So you'd lie through your teeth and just say, "Oh, it takes 5 days instead of 3. Now I got my 2 days for testing." Now at least people understand that. Testing has become such an integral part of what we do as engineers. We're also protesting the pro space testing, or pro dash testing. We're not protesting.
That would be a good alternative name for your project.
There you go. We're all for the act of testing, and management has kind of eventually come along for the ride. We need to do the same thing with documentation too, is I think what I'm trying to say.
I think one of the other things too, and we really didn't underscore it heavily, so I want to underscore it now, is technical accuracy, right? Like, we're writing technical documentation. There's nothing more important than the code sample being correct, that it runs. And so that's the other thing that this tool really does a good job of, is it makes sure that every single one of your code examples runs and exits with a 0, right? Like, make sure everything's proper. Additionally, like Mark was saying earlier, there's plenty of times you want to show an example of where it doesn't work, it's going to fail. And you even want to show the output of it failing. Well, a lot of tools do a really good job of, okay, if it's successful, we put it in, but if it fails, your whole documentation chain just blows up, right? You can't run it. We actually want to see when failures happen. And so the tooling allows us to say, I expect success and it has to compile with success, or I expect failure and it has to compile with failure. And I even want the output of the failure to show you exactly what I'm talking about. Like, this is how it fails. And that allows us to write a lot of code very quickly and never have to, that's your testing part of it, right? So, when you're writing code, you write tests. Well, this tooling, basically, I'm telling you, here's the expected output. Here's the test output I want. And that is super critical to this tool chain when you're writing technical documentation. Now, this is not just Go. It can be done with Java or Rails or Ruby or Python. It doesn't matter. It's not distinct.
Yeah, I think it's the UX of the docs is a really nice way of thinking about it. It's anytime, like, who's going to use this and what's their state of mind when they come to this? What's that journey you're going to take them on? I think that applied here makes a lot of sense. Well, I'll tell you what, you won't believe what time it is now. And if you check the doc, it does make it clear. It's time for your friend and mine, Unpopular Opinions.
I actually think you should probably leave.
Okay. Who has an unpopular opinion for us today?
I have 4.
You have 4 unpopular opinions.
Ooh.
I haven't been on the show in a while.
You've been keeping them in a bag of unpopular opinions?
I have. Maybe that's the unpopular opinion, is Mark shouldn't be keeping tabs on all these unpopular opinions.
Yeah.
Can I share all 4 or just one?
Well, let's do one first, shall we? And then see how we go. Pick your best one. Pick your best one.
Oh, but there's so many. I've got 4. I'll start with the one that always irritates me, and that's the main function is poorly designed.
Oh, interesting. Tell us more.
It should take arguments and return an error. That's my unpopular opinion. I don't like os.args. Global variables, thank you.
That's almost another one.
So that's my first one.
You almost got 2 out there.
Yeah, but that goes with it. That goes with the poor design. It forces us to use global variables.
Yeah, I agree, and actually have a pattern where I'll always call out to a run function that takes in the environment bits, like args, standard in, standard out, even standard error, and then also can return an error. And then in the main, all the main is only ever 5 lines where it calls that, and then you handle the global error once, and there's no global state, and it makes it very easy to test as well, because you can just call this run function like a normal function.
Yeah, I use a different pattern, which is like a commander interface, which is just the interface is main, and it takes, it's a main method. It takes a context, present working directory, arguments, and returns an error. And from that, I can pretty much do everything I want, because I can put IO on the type that has that interface, and I just call out to that in another package. So I get out of main as quick as I possibly can. But yeah, I think that, that's just a bit of drag. It would be so nice if we could just return an error instead of having, like, I understand we can control all that, but you could also control it or return an error.
What about just returning an error, though? What about the exit code? Because a big part of programs, as we've talked about already, is the exit code.
Mm-hmm.
And in C, like, it'll be often there's an int you can just return, and you just return the exit code. It's very clear what's happening when you do that.
Yeah, I think the way I would probably do it would be the default is, you get a 1 or something like that. If you return an error, maybe that error could also implement an interface that has a status code function on it, which is something I've also done in my own patterns. I've used that interface before, to check against an error and then use that. Or, if you really want to customize it, then you can just call OS exit yourself and you don't have to return anything. That would be the way I would design the main function. But that's just me.
Yeah. What do you think of that, Johnny?
I do like to keep as much as possible out of the main function. Not always. It depends on what it is I'm trying to accomplish. If I'm writing a quick sort of executable just to get something done and get it out the way, I don't spend a ton of time. It depends on basically the longevity of the code, right? If it is something that, and I'll say that I don't always write tests for, especially if I'm using libraries that are already tested. If all I'm doing is I have a main that's just using a library to do something, I don't see the value in removing code out of main to go put in something else, and then just so I can test that. All I'm doing is basically writing a project that integrates things that are already tested, right? So depending on basically what it is that I'm trying to accomplish, I may keep things out of main or just write the dozen lines of stuff that I need and call it a day.
Oh yeah, when we're all hacking scripts, that's a different argument. That's a different story altogether.
Well, I think that's where the design came from. The idea is if you want to write a quick script, it is easier to do that just having global state, but only in those simple cases. Otherwise, you don't want to overdo it. You puddle up that global space.
Yeah, but actually, I don't think that's actually a valid argument for the design, to be perfectly honest. I think that actually goes against it. Because if you really want easy, you wouldn't have so easy way to write a quick script. You'd let them return an error and give you arguments. You wouldn't have to reach out for global variables. You wouldn't have to handle exiting on your own.
Yeah, it's a fair point. I mean, I agree with you. Like, I'm in. So we could do this. Like, it would be possible. Like, we've got obviously the backwards compatibility. So you'd always support the func main, but you could probably, as a special case, have a new main that was different in some way. Like, it's not the end of the world, is it? It's possible.
Yeah, I don't think that's going to happen anytime soon.
No, but it's possible.
I just being realistic, I can't see that as a thing in Go. I mean, because now you're kind of getting into almost Java-like syntax where you have different versions of the exact same function. Overloading, yeah. So you've got a main that takes nothing and returns nothing. Then you have a main that takes args and returns an error.
That would be an error if you did that.
Mm-hmm. Oh, it would. It's just kind of weird to me to be able to do both. But
I don't like main. It makes liars out of us as trainers. Because as trainers, all we can show code snippets day after day of everything in main. And then we get all done, like, oh, by the way, never use main.
Don't
use main. Yeah, never use main. True. Like, out of main as fast as you possibly can. Like, do not stay in main. But we just spent 5 days showing you everything in main.
Mm-hmm.
And can I just go on record as saying I like the state of Maine? They have really tasty lobster, and we're not talking about you.
Oh, yeah. Yeah, thanks. Should make that clear.
I just want to make that very clear because I enjoy going to Maine for lobster.
You'll get letters, won't you, if we're not?
I will. I don't want anybody to think I hate the state of Maine.
Funky Maine. He called us Funky Maine. I don't know how they talk there. Probably like that.
No, they don't talk like that. They talk like they're Stephen King novels. There's a lot of, you can't get there from here.
Oh.
On that there road nearly killed a man. You got to watch out there for your son there, Jason.
Yeah. I like these people. Just based on that.
Yeah, very down home. Go watch Pet Sematary. Get a good understanding of the accent. So anyway, that was one of my unpopulars.
Pretty good one. Corey, have you brought an unpopular opinion today?
I do, and as a trainer, it's a kind of a harsh one. I don't think Go is an easy language to learn as a programming language.
Really?
And here's why. When you think about Go, I mean, one of the big things that kind of slaps you in the face with is it doesn't have inheritance, right? Which is a good thing, right? As Go developers, we know it's a good thing. But when you try to teach people Go, and their entire life as a programmer revolves around inheritance, not only do you have to teach them about writing code that doesn't use inheritance, like they have to learn a whole new way of even like looking at examples and samples. Everybody's got the shape example with inheritance or the animal example with inheritance, right? And so they understand, okay, like, oh, how do we do that in Ruby? And how do we do that in C++? And they, it all kind of has that same story to it. Well, Go invents brand new stories to tell brand new tales because we don't have the same tooling. And so not only now are you trying to teach new idioms for code, you're also trying to tell new stories that they've never heard, right? They have to learn the story as well. And I think that's what makes Go harder to learn. And it's deceiving because you can memorize the language in a day, right? Like you literally, like if you had to take a test and say you need to know every single symbol that comes in the Go runtime by tomorrow, everybody could probably do that. 130 words roughly, right? You could do that. So in a day, you could literally memorize the language, but you don't know the language. You're so far from being an actual credible Go developer. It's not even funny.
Yeah, that is a very good point.
I agree. Coming, we've seen this as trainers, and Johnny, I'm sure you've seen this too, in the same thing. When people are brand new to kind of coding in general, they can get Go a little bit faster, I think, because they're not pulling those preconceived notions. But when I'm teaching a group of Java developers or .NET developers or Ruby developers, even to some extent, all of a sudden there's these tons of preconceived notions around statically typed compiled languages, how they work, how things get done, what those patterns are you need to use. And I think people do get really caught up on the way Go does things, which, it is a little different in a lot of different ways, so it can be difficult, I think, if you're coming from another language.
There's been times in class too where someone asks, well, why don't you do this? And I'll literally just finally say, because we just don't and go. Like, we just don't. I can't even tell you why. We just don't, you know? Or the amount of times people say, what happens if you do this? I'm like, I have no idea. And they're kind of like, well, wait, you're training Go. How do you not know what happens if you do this? I'm like, because you would never do that in Go. Like, it would never even occur to you to do that in Go.
Yeah.
But let's do it. Let's run it. And sometimes you're shocked that it actually works. You're like, I can't believe that actually works in Go. And then other times, like, yeah, compile time error, exactly what I expect, right? But that's where it goes just so different that it's, and so when then like for training, like we do these boot camp style trainings, right? So in 5 days, you're trying to impart, 6 months of knowledge onto these students, right? And it's complete brain overload every single time. And the only saving grace you have is the fact that, you've shown them everything and now they can come back and reference it later, right? Because, we spend a day and a half on concurrency. Concurrency should be 2 weeks, right? But you're going to get a day and a half, right? You're going to get 6 hours. That's what you're going to get. But good luck, right? We got you. And so it's great, and concurrency is fine when you're doing weight group, right? Hey, this is easy. Oh, now I'm going to introduce channels to you. And now I'm going to show you the SLA pattern where I'm going to actually time out and make sure that if I exceed a certain amount of time that I return early. And hey, there's this thing called the blocked go routine now you have to look out for. And here's what happens there. And by the time you get to that point, people are like, what are you talking about? Like, concurrency was so simple. And now I have no idea what I'm doing.
Yeah, as soon as you bring channels into the mix, concurrency gets really complicated.
Yeah.
Well, and I show an example of where I retrieve 100 websites concurrently, and I use the sync.wait group to do it. And I literally just take an example that just, is in a for loop and calls out, 100 times. And in 5 lines of code, I can make that work with the sync.wait group concurrently, right? 5 lines of code. Now, to get that same code to work with channels, literally the code is 4 times as long and doesn't even look the same anymore. Now it's production ready this time, right? Because now I can handle things like timeouts and send the errors back in the right spot and all that kind of good stuff, right? I can manage, I don't want to have 100 connections at a time. I can manage, I want 20 connections. So now I got connection pooling built in. You've got all this stuff going, right? And it's totally production ready and it's 4 times the size. Whereas the sync.wait group was 5 lines of code I had to change, right? But I would never ship that to production.
Okay, well, yeah, good one. Pretty good, that. Interesting. I mean, I agree. Like, in fact, I do ship weight group stuff to production. Like, if I can get away with it, because it's so much simpler. Yeah.
I use Air Group mostly, but
what? Error group.
Yeah.
That still gets me. See, and I can't get behind it because it never made it as a real function, right? It never made it to the standard library. So for me, I'm like, nope, it never made the grade. I can't use it. It stayed experimental forever.
It works. It's nice.
It's a batch failure only.
Most of the time, it does pretty much exactly what I want. Just, I usually just care about getting.
Tell us what it is, please, Mark.
Yeah. So what Air Group versus Weight Group is that you can get the error back. So if you launch 100 Go routine, it'll wait for all 100 to exit. But whatever one returns an error first, it reports it as the error. So if you just need to know that anything in there failed, you can basically abort your batch, which is kind of that concept. But if 25 errors occurred, you're only getting the first one back. Most of the time, I need to know all the errors, right? I need to know everything that happened to report that. But there is a set of use cases where you're doing batch programming, where you're going to kind of roll the whole batch back, and any error says roll it back, then that's where it works.
We do have multi-error now in Go 120, and if you want to learn more about that, I suggest you listen to the episode with Carl Johnson and Johnny and I. It's a great one, and he talks about that new multi-error that's coming in Go 120.
It's already here.
It's here. That was the Stephen King line from Maine again.
I know it's yet one more thing I have to go update my documentation for.
Right.
Exactly.
Yeah. All right, Mark. I think we've got time for another one of your unpopular opinions. I feel like you've done 3 now. I'm counting, but
okay. So imports for side effects.
Oh, bad.
Awful idea.
This is not going to be unpopular.
I want to slap whoever on the wrist thought that was a very good idea to use in the standard library, and it's used in several places.
So just for people who don't know, this is where, because we have the init function that you can run and just runs like...
Which is also bad, but go on.
When the program just starts, yeah. Good for like some cases, again, it's like easily abused, one of those. So just by importing a package, you actually then that init code will run and it's kind of hidden and it can do things. It can like you can change the default HTTP client, for example, and things like this. And I've seen code that does that, but it's a surprise every time, isn't it?
the biggest, the one that everybody kind of runs into is importing database drivers to register with the sync pack with the SQL package, and we all do that. We put the little underscore at the very, to keep that package imported, even though we're not directly using it, because all it's doing is running an init function, which calls back to the SQL package and registers itself. And that's just and then if you try to you have no control over this registration either. If the registration fails for any reason, it panics.
Yeah, it has to, right? What else?
Yeah, because you've got this weird system for registering code, where what it should be is if you're going to make me register at the package level, then give me a function or method, to call that would return an error if there's a problem with the registration. Right.
So you'd just rather have an explicit call, wouldn't you?
Yeah, of course.
And it could be idempotent too. Like that's the other thing too. Like because whenever I teach that topic, I teach the side effect, and I show them the only reason you have side effect is you have an init. Neither of one you should ever do. Like avoid it at all cost because it's magical, and we're not in a magical language anymore. But then it really is one of those things where I'm just like, why didn't they just make an idempotent call, right? Like the image package is a great example, right? I write a piece of code that compiles, it runs just fine, but when it goes to actually decode a PNG file, it fails. Why? Because I didn't import the image PNG package. Literally, I make the code pass by adding a side effect import. That's the only thing I do to the entire code, and that now it passes and it works, which is so wrong. Like that should not make my code work.
I have a feeling I think the people, whoever came up with that, would probably agree now. Like sometimes things are just in the standard library. It was written at the time really before these things were established. It's kind of amazing to see this change.
Oh, as a trainer, that's one of the biggest things we fight against constantly. I'm constantly telling people not to do what the standard library is doing in their face all the time. Like where I'm sitting here saying, don't do this very pattern, yet we can name numerous examples in the standard library where this is happening. And this is like a known pattern encouraged by the standard library.
The good part about being the trainer, though, is that when people get really upset about it, the answer is, well, listen, I didn't write it. Like, I didn't write
that's
the
what I always
I didn't write it. I mean, why do they do this? I don't write it. I don't know.
Yeah, I don't. So yeah, hopefully, I understand maybe why it was written that way when it was written, but even then, it still would have felt wrong because there's this level of magic.
That should have been the first red flag that went up when they put the init in. Should have been a major red flag. Like, wait a minute, this all of a sudden feels magical. Nothing else in Go is magical. Not a single thing, but this little init thing is magical.
Oh, don't forget the magic. Okay.
Yeah,
that was one of mine once. One of my unpopular opinions was I would make you always have to have both arguments and use an underscore. Just preferring explicit and verbose over anything magic. Yeah, and that's very Go.
Like, why, for example, here's another unpopular opinion. This wasn't even on my list. Why can we do type assertions without checking for the magic? Okay.
Yeah. Well, it's if you know it's going to be that.
Yeah, but if you know it's going to be that, then why are you taking an interface?
Now I feel like I'm preaching to my students, like, no, because you only know it today. Tomorrow, when somebody changes your code, they break it, and it panics in production, and somebody hunts you down at 3 o'clock in the morning. Says, why is your code broken?
Yeah, and if you're expecting a bytes buffer, take a bytes buffer.
Yeah.
Don't take an interface and then do a hard type assertion against it. Like, no, like, there's no reason why you should be in that middle ground of I don't need to check the okay.
You might find generics helps with that a little bit, because I think sometimes it's where they support multiple things, but again, it's quite magic. So you can have the strongly typed alternative methods instead, which I'd probably prefer.
Now you're touching on my unpopular
opinion.
Okay,
Johnny, let's do it, shall we?
I think we put generics in Go to shut the critics up, not because we really needed it.
I agree.
Yeah. I use them for a few things, but I'm not like, my code hasn't changed radically because of it. Maps. Maps are like the number one place I use it, I think.
There were some nice things it did, right? Like maps, like slices. I can do like the slices.keys, slices.values. Like that was kind of nice. But they could have done that without introducing generics. They could have just done the syntactic sugar in the runtime or the compiler, like whatever it was going to be, and done those things without introducing generics, because generics are going to ruin the language. You give it another 2-3 years, like you're going to see the worst code ever. And the fact that we didn't have it forced you to get it right. It really did. You know, again, there's a place for generics. Like
I don't know if they're going to ruin the language, because as they are right now, they're so weak and so limited in use.
So I always tell people, Go doesn't have generics. They have generic function and method signatures. There's a big difference.
That's it.
Right?
Yeah, right.
And
Very
I think people when we say generic for other languages, that means something radically different than what it means for Go. We just have generic signatures in Go. And I think that is a good thing, right? Like that, like true generics would have been a disaster. So that's kind of good.
Parametric polymorphism.
Ooh, that sounds like fun.
That sounds like a Harry Potter spell.
I'm gonna have to go and get a CS degree, I think. It does sound like a Harry Potter spell.
Our unpopular opinion is too unpopular.
Well, we'll test these on social media because you might be surprised. We often are surprised. What we should have, because it's hard to know, like usually they hear the case made very clearly, and that's what they're voting immediately afterwards. What we should have is devil's advocate, where someone makes the opposite case. Because I could make the opposite case for yours, Johnny. Is that why they did it? Like,
it's not the only reason.
Do you think?
I don't think it's the only reason, but prior to the critics and everybody saying, oh, Go is for such a modern language, it doesn't, it lacks modern features such as blah blah blah, right? I mean, when Go came out, I never heard anybody in the Go team or even the co-creators, like folks like Rob Pike and whatnot, talking about that, oh yeah, the language is not complete because we're missing generics or anything, like some things of that nature. It's that only came about really from I heard about the missing feature from the critics. When they became popular, popular blog posts of YouTube videos, and people are like, well, yeah, why doesn't Go have generics? And it kind of became, and I was
Stephen
like,
King film,
okay, I've been writing production Go code for years, and it's not something I'm like, oh, you know what would be really good here? Generics. And because I can't F this language, right? I mean, it's like, I don't know. It's just, to me, it feels so much like we're trying to appease people.
I'm with you. I felt the same way. I had no idea what generics even were because I'd never worked in a language with generics before.
Yeah, but you used Ruby, mate, which is basically the whole thing's just generic. Just do whatever you like.
Meta programming, a.k.a. generics.
But Johnny, if that were true, that this was to silence critics and a sort of PR exercise, is that worth doing? If people were turned off because they just thought, oh, it's not good enough, even if they don't need don't have a particular use case for it, is it worth doing things like that to satisfy the community? Like devil's advocate.
Well, don't get me wrong. The generics has its uses, or rather, for the sake of this conversation, I will start calling it generics and start referring to it as parametric, polymorphism, right? That is very useful, right? I've come across, situations where I have some boilerplate code, mind you, new code that I'm writing. I never go back and refactor non-generic code to be generic. For me, that's a no-no. If I'm writing new code and I'm finding, okay, there's a lot of boilerplate, especially if I have to put, create, take, for example, if I'm writing multiple sum functions or something, I need a sum float and a sum int and a sum whatever. And I'm like, you know what? The body of this function is the same thing with all of these functions, right? Things that I would normally take care of with a Go generate or something like that, right? Now I'm like, you know what? Yeah, I can probably just refactor this into just one thing, take in a type constraint and just call it a day, right? Like that those use cases, great. I can definitely see the usefulness of that. But anything beyond that, honestly, I've had I'm like, was it really that necessary? In my view, it was useful. I think it needed to be there as a modern language. We needed to have something of that nature, but I don't think it really truly revolutionized the language as much as people thought it would.
I agree. I have a synchronized map type I use. It's a struct, and with that, I can set the key and value with generics, and that's really nice. That to me is one use case where it's been incredibly helpful. I have this nice synchronized map that I can use the exact types I want for. And that's, it's that. And then it's basically, after that, it becomes map reduce functions.
Yeah.
It's essentially that's pretty much all that's left. Because even what Johnny was just describing was essentially a map reduce when you're talking about summing.
Yeah.
you know, that's
Yeah, but like data structures and things like that, like I can see a use in that if you have the same kind of thing, but in with different flavors. But yeah, again, I mean, I don't know. I haven't used it a lot. We want to do an episode, and this is a shout out if anyone's got any good examples of places where you've used generics and you thought, yes, this is right. I'd love to do a kind of generics in the wild episode of Go Time and look at some good use cases.
I just told you mine. That was it. It's 30 seconds of the episode.
Yeah, but you did it in the unpopular opinion section.
I have one place where I found them really useful.
I would caveat that request, though. I would say beyond like just I don't want to see just map reduce or slices and maps, right? Like outside of those three scenarios, right? That's where I want to see, because I'm in complete disbelief that it's useful outside of those scenarios.
I've got one. JSON marshalling and unmarshalling. Like you can just have a method, strong types.
So yeah, when it comes to like ORM type stuff, like I can see that, like database, like anytime you're marshalling anything, right? Like I can see that.
If we do bring someone on the show for that episode, I think we need to bring. I think perhaps you and I, Matt, would be balanced in our view of it. At the very, I'm not gonna speak for you. I will take a very balanced view of it, but we should definitely bring someone who's pro generics and hopefully bring examples of how it has improved their lives, considerably. And then we should bring somebody who's anti, right, who sees no value, right, and ideally, we should bring people who had gripes with Go for missing generics, and now bring them on the show and talk about, okay, now that the language has those features, have you actually used them, right? Like, how has your life improved? Did you get what you wanted, right? I want to hear from those people because they were very, very loud. Like, come be loud on the show. We want to hear from you.
Yeah, I think that's fine. I mean, it's a bit scary the way you pitched it, but I think yes, I think definitely. And if that's you, please reach out. We're on we're GoTime FM on Twitter. We're in the Gopher Slack in the GoTime channel, GoTime FM. Or you can get through changelog.
And you can also find Go Time by searching for Go Fundamentals by Gopher Guides on Google and Amazon.com.
Shameless.
We're not doing shameless plugs right now? I thought we were. Sorry.
That's another section we should start. It should have its own little theme tune.
The shameless plug section?
Yeah, like ding 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 boom, something like that. Like bouncy and yeah, be nice. The book looks good though. Where can people get it? Is it available now?
It is available now at all fine bookstores near you. So no bookstores near you because they don't exist anymore. But if you can find a big bookstore, you might find a copy in there because they do have them. Or you can just go to Amazon or all that good stuff. Just search for Go Fundamentals by Gopher Guides. They make great Christmas presents, Hanukkah presents, birthdays, divorces. Really, any kind of party you might be going to, any sort of special occasion, really. Stepfather's Day, Arbor Day, huge. People love getting a big paper book on Arbor Day to celebrate the trees.
Never heard of that one. But...
Exactly. Why not celebrate Arbor Day with a paperback copy of a 600-page book, folks?
Have some dead tree with your live ones.
Exactly. Nothing says be green this Arbor Day.
Well, unfortunately, that's all the time we have today. Thank you so much, Corey Lanou, Mark Bates.
Thank you.
From Johnny Bossico, myself. Thank you, Mark and Corey. See you next time on Go Time.
That is Go Time for this week. Thanks for listening. Did you enjoy the fake movie trailer at the top of the show? Could you identify all the clips we pulled in? Here they are in order of appearance. The Imitation Game, Terminator 2, When 007 Has a Gen Z Villain from Stephen Hea's YouTube channel, Dumb and Dumber, Full Metal Jacket, The Simpsons, and Terminator 2, again. Thanks once again to our partners Fastly and Fly for helping us bring you Go Time each and every week. Check them out at fastly.com and at fly.io. And to our Beatmaster in residence, the mysterious Breakmaster Cylinder. So mysterious, so cylindrical. Next time on Go Time, Matt and John welcome back Carl Johnson, this time taking up a listener request by discussing the parts of Go they actively avoid and why. Stay tuned for that. We'll have it ready for you next week.